Hey folks, this is the next video in sort of our list slash array series, and we're going to be talking about vectors. So vectors are really cool. They're sort of a newer addition to C++. I say newer, it's still 10 plus years old. But it's new to kind of the original flavor of C++. So, when we were talking about arrays, we were talking about, we were always, making, static arrays. This idea that, like, once I get 10 things in my list right here, once I declare it's going to be of size 10, like, it's pretty rigid, right? Like, it's, okay, cool, it can hold 10 things. And if we want to change the size of it, we gotta make a new array, and it's a little bit awkward. So it'd be great if we could have something that's more flexible. Like, I don't know how many things are gonna get entered in this. Oh, maybe I'm gonna be listing a bunch of deposits that I'm gonna get from the bank, and I want to keep track of all the deposits. But different people are gonna use different amounts, right? Like somebody might have 3 deposits in a month. Somebody might be adding and subtracting money like a business or something like that, like a couple of times every day. So you don't know whose list is going to be what size, and it'd be great if you could sort of cut down on having to know about or guess about that ahead of time. So to get involved in this, we're going to add a new include statement up at the top, which is vector. Just how it sounds. Now it's a little bit weird because vector, we're pretty comfortable with vector, or from physics or math class, and so it's a little confusing because that language overlaps a little bit, and they don't really have much to do with each other. But if you get them as a dynamic list in C++, that's a better way to wrap your head around it. So the other thing that's kind of interesting about vectors is vector uses a very different style of declaring stuff because it has a templated feature. It's one of the ways you can tell it's kind of a newer item. So if I want to make a vector of integers, the type, so like usually the type is just this word ahead of the variable name. The type is actually like a little more complicated. So we say that it's a vector object, and then we use these little templating brackets here to throw in what type of thing that we want. So if we want a vector of integers, we put integer inside this basket, and then we can just call it, I don't know, I'll just call it numList, okay? And there you go, you stop. You don't have to initialize it, because what this does is it actually starts off, if we kind of use that filing cabinet analogy, it starts off as an empty filing cabinet. Like there's no file folders in this cabinet yet. So I have to say, like, if I want to save something in this, I have to say, well, add a folder and put something into it. Turns out that there's one handy dandy command to do that, which is the pushback command. So again, this is like a little different style of manipulating things than what we're used to. So here I'm going to go numList, and then I'm going to use the pushback command, and then I'm going to say like what I want to push back. Oh, I'll put push back a 7. Okay, and then just okay. Well, let me just print out what I just put in there. So here we got a couple of things. So one, we said we made the list, and then we said, hey, take that list and push back the value 7. And now we started off with nothing in it, but now we're actually going to have the first box is sort of going to get made because it gets made on demand. And you can see here that we got a nice 7 popping up, okay? So definitely feeling good about that because we ended up with something in there, okay? And it's in the first spot on the list. So what pushback does is it basically says, like, create a box and load whatever that value is into it. So for instance, if I made a vector of string, okay, type string, it's going to hold words. Let's call it word list. I would do word list dot pushback, howdy. okay? And then if I went in here and I looked at word list at spot 0, we got howdy right here, and we're feeling great about ourselves, okay? So that's the general strategy that we're going to use, is that we can push back values. So how does this work in sort of the real way to do it? Well, let's say I can say I'm going to have a bunch of inputs. I'm going to make a little while true loop. So, when we don't know how many times something's going to happen, that's a great time for a while loop, or certainly a loop that's, goes on forever. So I say while true, and I could say cout, enter in -1 to stop. Otherwise, I'll save your number. Cool. So now, what am I going to do? Well, I'm going to make a temporary variable. So, well, I made a up there, so I'll just use a as my temporary variable. And then, so I'll say cma. Awesome. And then I can say, if a equals -1, then I'm going to, break out of my loop. Okay. Otherwise, I don't even need an else statement here. What am I going to do? I'm going to say, well, numList dot push back the value of a. Okay, so I can do that for a little bit, and until I type in -1, I'll get a list of numbers. But I want to see what I printed in. So this is going to be the for loop that we use to print all this stuff out. You've probably noticed by now that for loops and lists in general are really well tied together, because we're going to be using the list to sort of step through everything. So here, I'm going to make my little counter. I'm going to start off at 0. And this is my favorite part about lists, or vectors, is that I'm going to say, well, I is less than numList dot size. So the list, this vector, okay, because it's a little fancier than the array, it's got a lot of built-in sort of cool functions, and you can go look them up on C++, a resource page to kind of get like all the power of them. But you can do some really great things where you can like erase individual elements in a thing. You can clear out the whole list. So I'll show a couple of those here in this, but there's really a lot of power there. I really like that it'll report its own size. So now I don't know how many things were in the list, right? I mean, because it depends on the user. So the user does that, and then now I can be flexible about how I print all this stuff out. So, and I'm just going to only go through the loop as many times as I need. How many times is that? Well, however long the list is. So let's run that real quick and see what it looks like. So I typed in a few different things. I'm going to type in -1, and hey, look, I got 5, 6, 43, 2, 3, 4. Saved off all the information, didn't have to do anything fancy, and I have this sense of like, hey, I was flexible. I only saved as much information as I needed to, and that's really nice. And so when I don't know how many things are going to go into it, I really want to use this. I'm going to use numList.size. So what are some other nifty things you can do? Well, you can do numList.clear. Okay, so if I do that, and I type in a few things, and I type in -1, you'll notice that when I typed in -1, nothing printed out. Why? Because I stored a bunch of stuff in it, but then I actually did the clear command. Clear completely empties the list. That's really useful sometimes if you have a nested list, right? So if you have a list inside of a nested loop. So I have like a for loop, and then I build up some list, and then I print it out, and then, oh, I'm going to build up that list again. I might clear it out as part of starting some sort of double loop thing. So that's pretty nice. The most common way that you're going to end up doing that double loop thing is that vectors can hold, it's going to be a little crazy, is vectors can actually hold anything, right? So what's the thing that it can hold? It can also hold another vector. So And that's crazy. So what that really is if I make a vector that holds other vectors, I'm really saying is I'm making a list that the components of it are other lists, right? And that's a really powerful, concept. You might not use that a lot, but if you ever need to use it, it's right there.